Okay, guys, so I want us to take a look at the warm-ups and talk about how we do them, and we're going to check their work up there. So the first problem was to find the vertex of f of x equals 4x squared plus 8x minus 11. Taylor, how did you find that vertex? What did you use?
I used the negative b over 2a.
Right, so we have a, b, and c, and so she had to do negative b over 2 times a. And so that was negative 8 over 8, and that gave her negative 1. So that part is correct on her vertex. So she knows that the x-coordinate is negative 1. So what did you do now, Taylor?
I put the x-coordinate into the equation.
Right, so we're really doing f of negative 1. That's what that means. So in this problem, wherever we have an x, we have to substitute in a negative 1. That's what the notation means on that. So we get this. So now we're going to check that. Now, everyone, do we do 4 times negative 1 or do we do negative 1 squared? Negative 1 squared. You have to do order of operations. So negative 1 squared is 1 times 4 is 4. So it's going to be 4 minus 8 and then minus 11. So 4 minus 19. Do we agree with her answer of negative 15? Yes. So her vertex is correct. Let me remind you how we could have checked this on the calculator. So the calculator check is this. I'm going to put in my 4x squared plus 8x minus 11. I'm going to do a zoom 6. I'm going to see if I can see the entire parabola. Why can't I see the bottom of it? Negative 15 is going to be my low point, right? So I can adjust my window and I can make that y min go down to like negative 20 just in order to be able to see that vertex. Now I can see it. When I go to second trace, which one of these is going to tell me the vertex? Minimum, right? So I go down to the minimum and it's going to say what's on the left of the minimum. I arrow over, I push enter. Now it's going to say what's to the right of the minimum. I arrow over and I push enter. And then it say, do you want to guess? I push enter one more time. And here's going to be my minimum right there. I want to see something. Okay. So my minimum then was at negative 1, negative 15. Remember that the calculator, sometimes when it counts the pixels, it's just trying to be too exact. There, that time. Sometimes when you go back and then come back to it again, it gives you the exact answer. I don't know, it's weird like that. So there we go. The next thing we had to do was find the axis of symmetry. Remember that axis of symmetry comes straight down through that vertex. Okay? And so let's see what, and if you're, what you had, x equals negative 1. Sounds good, doesn't it? Because it has to come straight down to that vertex. So that is going to be correct. Very good. Find the 5 key points. Okay, so they have their points over there. How can I check those points on my calculator? Does anybody remember where we can go to see a bunch of points? Where do we go, Halima? Right. So if I do second graph, I get to my table. Now I had jumped up to 410 for another class, what we were doing. So I'm going to have to go set up my table so that I start at 0. You guys wouldn't have to do that. So here we go. I'm checking their table of values. So we're all those points in there. Go up a little bit to see them better. And we can see that those points are correct. Okay? On a test, you could just go directly to your table of values, couldn't you, if I allowed you to use your calculator? All right, number 4. And remember with the 5 key points too, guys, that vertex right here, that needs to be in the middle. You always want to have that, and then you want to go out this way, and you want to go out greater than. And so, let's see, 1 and negative 11. And because of that symmetry, once we know that, we know that. And same. All right, factoring. Some of you still have a little bit of trouble with factoring. So let's talk about how we look at this. First of all, anytime we have a quadratic, it must be set equal to 0. So we're good with that. We look here first. Numbers, values that multiply to be x squared would be x and x. Now we look here. We want numbers that multiply to be 12. What are our options? 1 and, 2 and 3 and. Okay, so we have all those options. We want to think of the ones that multiply to be 12 and subtract to be 4. So of our 1 and 12, 3 and 4, 6 and 2, which ones are we going to use? 6 and 2. So we got our 6 and our 2. Which one now, when I do my outers, I get a 2x. When I do my inners, I get a 6x. We want to get a positive 4x. So how would I do the signs? Negative 2 and positive 6. That gives me the positive 4x that I need. So I need for my 6x right here to be positive, my 2x right here to be negative. So therefore, the solution should be, if I set this one equal to 0, subtract 6, and set this one equal to 0, add 2, and there we go. How can I check it on the calculator? Say I'm taking the ACTs and I had to solve this and I want to just double check. I have time. Well, I can put it into my calculator, and then, can anybody think of one way I could check it? There's 2 different ways. What can I look at? Table, right? I can go to my second graph to my table. I want to find the points. Negative 6 what? 0. I want to see negative 6, 0. There it is. That's good. And now I also should see the point 2, 0. And I do. So that's good. The other way is, once I have it in here, I can put in y equals 0. I graph it. Here's the way it looks. So I'm trying to find out, what is this intercept? What is this intercept? I could literally count 1, 2, 1, 2, 3, 4, 5, 6. But I could also do this. Second trace, which one do I go to? Look what functions I have in, guys. I put in my parabola and I put in y equals 0. So when I go to second trace calculate, which one am I looking for? Anish? Intersect. So I go to intersect. Let's say I wasn't sure about this one. We'll arrow over close to it. It says first curve, I push enter. Second curve, I push enter. And then one more enter, negative 6. So I know it's correct. All right, let's look at the last one. If you look up there, we weren't exactly sure how to do this. We always have 2 ways of doing these problems, algebraically and graphically. Let's say you did not know how to factor this. You could do it on the calculator. Look, I go under y equals, I'm going to put this in, 2x squared minus 11x minus 6. I can do a zoom 6, or I can just hit graph. Here's my zoom 6. There's the way it looks. I want to know, where is the parabola 0? Right here. That's where the parabola equals 0. That's where the parabola equals 0. Those are called x-intercepts. How do I find those on the calculator? What did we just do, guys, to find those x-intercepts? Noah? Which one? Intersect, right. So I go to that intersect. I'm going to get close to this one. Enter, enter, enter. What is it? Negative 0.5, which is the same as what? Negative 1/2. Then I could also find that one. That's how I can do it on the calculator. Now, we also need to know how to do it algebraically. We have our double parentheses set up. I'm going to look here first. What values multiply to be 2x squared? 2x and x. Next, I'm going to look here. What are numbers that multiply to be 6? 1 and 6, and what else? 2 and 3. Now, I need for my outers and inners to combine to give me a negative 11. And you will never put the same number in one parenthesis. For example, if I have a 2x here, I will never put a 2 here. If I have a 2x here, I'll also never put a 4 here, a 6 here, an 8 here, a 10 here. They'll never have a common multiple. So if I choose to use this one, what's the only thing that could go here? 3. But that's not going to work. Look, if I put a 3 here and a 2 here, think about it. I would get a 4x and a 3x. Are those going to give me 11? 4x and 3x? No. So I'm going to have to try this instead. Can a 6 go here? No. The 6 is going to have to go here. The 1 is going to have to go here. Now check it. This gives me a 12x. This gives me a 1x. I'm trying to get a negative 11. Which one needs to be negative for that to happen? 12x must be negative. This is where my 12x is. Has to be negative. This one has to be positive. So once it's factored, I can do 2x plus 1 equals 0. X minus 6 equals 0. Solving this, I'm going to get 2x equals negative 1. X is negative 1/2. Add your 6. X equals 6. Look back at our graph. See that? Negative 1/2 and 6. All right? In my last class, somebody got positive 1/2 and negative 6 for the answer. Can you see how just by looking at the graph they should see that's not right? Because obviously this is positive 6, not negative 6. Tim? Did you have a question? Anybody else? Any questions on anything? So use your calculator. If you have no idea of how to solve this by factoring, use the calculator. But if you know how to factor pretty well, go ahead and do it algebraically. You've got options. All right, guys, we're going to go straight into the notes. So get out your student journal. And we're looking at page 32. Actually, let's go to page 33. All right, so page 33, we're looking at numbers 4, 5, and 6. Those are the 3 problems we're going to do. In exercises 4 and 5, graph the function. Label the x-intercepts, the vertex, and the axis of symmetry. All right. This function is already factored for us. It's like in our warm-ups, right? In our warm-ups, this problem would have been easier if it was already factored for us. We could have quickly found our x-intercepts. So this one, in this form, it's already factored. So I'm going to first find the x-intercepts. At x-intercepts, what's equal to 0? X or y? Y. So I'm going to set f of x, that's the same thing as y. I'm going to set that equal to 0. First, I look at every factor. This is a factor, this is a factor, this is a factor. Can 4 ever equal 0? No, I'm not going to worry about that. If I have x plus 4 equals 0, what's that going to be then, guys? What's going to be that intercept? Negative 4. X minus 3 equals 0. What's going to be that intercept? X equals 3. Okay, so now I know I'm going to have negative 4, and I'm going to have 3. Those are x-intercepts. I also have to find the vertex. Can anybody think of how I can find the vertex? Anish?
Well, since you know it's a quadratic function, then you can find the median of the 2 points and know that that's the line of symmetry.
Exactly. Parabolas are symmetric. So in the middle of this has to be where the vertex is. So how do I find the middle of -4 and 3? You got it. Okay, so first I'm going to say x-intercepts are -4, 0, and 3, 0. So my vertex then is going to have to be add these together and divide by 2. So -1 divided by 2, that's -1/2. How do I find the y-coordinate? Because it's not 0. Plug it in, right? I have to plug it back in. So I'm going to have 4 times -1/2 plus 4 is 3.5. And -1/2 minus 3 is -3.5. This would be a good time for a calculator. Don't grab it all the time, but for something like this, it's useful. Okay, so -49. Kind of tough to graph that point. I'm going to have to make this one go by tens. So my x-axis, I'm going by 1. Here I'm going to have to go by tens. I'll have to call that -10. So that's going to be -10, 20, 30, 40, 50. So we're going to be at -1/2, -50. So because I had to change that scale, and I'm just going to label this so we know. So there's the way it looks. Axis of symmetry, what is it? It just comes straight down through here. What's it going to be, guys? X equals -1/2. Great. You don't need to follow along, but let me show you something here on the calculator. Sometimes people say, yeah, but I can't really check that on the calculator because it's just so different looking because we changed that axis. But watch what I can do. On my window, I can say my x's are going to go from -5 to 5, just like on here. And I'm going to say my y's are going to go from -50 to 50 and go by tens. And watch how accurate this is going to look now. See how it looks just like ours does? Because I made this axis, I squished it together and made it go by tens. So much you can do on the calculator. All right, let's try this one now. We want to find our x-intercepts. So is it possible for -7x to equal 0?
Yes.
What would make that happen? So it would be 0, right? So we have an x-intercept at 0, 0. Now we have to set x minus 6 equal to 0. What's that going to be? 6. Okay, so there's our x-intercepts. Check. Vertex. Let's have somebody new. Danielle, can you tell me where the vertex would be, what the x-coordinate would be? What's in the middle of these two? 3. Okay, so my vertex then is going to be at 3, comma, and plug it back in, right? So -7 times 3 is -21. 3 minus 6 is -3. So what's that going to be then? 63. I love how they give us those numbers when they give us this tiny axis. So this is going to go, let's see, 10, 20, 30, 40, 50, 63 is just right about in there. Oops, I got to go over 3 units though. So I can go over 3 units here. 63 is right about there. I have 0, 0, and I have 6, 0. 1, 2, 3, 4, 5, 6. So there's our graph. Got that vertex. Axis of symmetry. What's that going to be, Clara? The axis of symmetry.
X equals 3.
You got it. All right, very good. So we understand that. Let's do a tougher problem now. A softball player hits a ball whose path is modeled by f of x equals -0.0005x squared plus 0.2127x plus 3, where x is the distance from home plate in feet and y is the height of ball above the ground in feet. What is the highest point this ball will reach? If the ball was hit to center field, which has an 8-foot fence located 410 feet from home plate, was this hit a home run? All right, so what are we going to do? How can we find the highest point that this reaches? What could we do? Any ideas? What can we do in it here?
We could put the equation into the calculator and then you could choose the maximum.
Excellent. How do you know it would be the maximum we're trying to find?
Because the coefficient of x squared is negative, so that means that the drop low opens down, and when it opens down, it goes down.
Awesome. He's right. Okay, so let's go to our calculator and let's do what he said. We're not going to find this vertex by doing negative b over 2a, are we? That would be a little tricky. So let's do negative 0.0005 x squared plus 0.2127x plus 3. So get that in your calculator. All right. And so now we want to graph that. But if I just hit graph, all I'm seeing is this. Okay, that doesn't really make it very accurate. So I'm going to have to use some common sense, and I'm going to have to go back to my window. All right, so this ball is on the rise. It's going up, 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 and it's going out, right? So I need to make this x max much higher, maybe 200. I don't know yet. What do you think? The height didn't look too bad, did it? So I might not even want to change that. You might want to keep it at negative 50 to 50. We'll see. So now hit graph. All right, so now it looks like that. I'm still trying to see this whole parabola, where it's going to hit the ground. So I'm going to have to extend the window even more. What do you guys think? What might I want to go to? 400? Okay, let's read this. If the ball was hit to center field, which has an 8-foot fence located 410 feet from home plate. So we're talking about an X distance of 410. So what might be a better thing to put here? 420, 450, whatever. Something larger than 410. Let's see what it looks like now. So here's the path of our ball. It's on the rise, then it comes down. Okay, that's a good graph there. All right, so now we want to see what's the highest point this ball will reach. Do you know where to go? Alexis, do you know where we go to find the highest point? Second trace, right? And now which one do we want? For the highest point. Maximum, good. So we're going to go to maximum. I have to go to the left side, just anywhere to the left. That looks good. Anywhere to the right. I got to make sure I'm to the right of that highest point. That looks good. And then one more enter. So what is the highest point? Is it the 212.7 or is it the 25.6? 25.6 because that's the y value. Okay, so now we know A, the highest is 25.6 feet. All right, part B. Got that. If the ball was hit to center field, which has an 8-foot fence located 410 feet from home plate, was this hit a home run? So here's what happens. The ball's going out. The question is right here, a distance of 410 feet. This is an 8-foot high fence. Does the ball get over that fence for a home run? What do you guys think? Yes or no? No? Some people say no. I saw a few yeses. How can we figure it out? Trace? Okay, trace. What?
Count.
Second trace? Value. Okay. I like it. So he's saying then, at 410 feet out, how high is the ball? So the answer is no, isn't it? It's not going to get over the fence. It's going to hit the fence. In fact, probably some outfielder would just reach up their hand and it would be an out rather than a home run. So no. ball must be 410 feet, must be 8 feet at 410 feet horizontally or something like that. However you want to word that. All right, makes sense? So on your homework, use your calculator when necessary. On problems like this where you have these crazy decimals, you're probably going to want to use your calculator to find that vertex rather than trying to do it algebraically. Remember that when we have x-intercepts, in the middle of those x-intercepts is always where that vertex is going to have to be because of the symmetry of that graph. All right? So for homework, just go to Canvas, find your assignment, and you'll be good.